And I think we're live. I think so. Okay. Well, welcome everyone to IPLD Weekly Sync for 2021. So we are without Volker today, but everybody else is here. So let's get into it. We're going to go do a quick stand up. So Daniel, you're first.
Cool. So this is my first week back, so I haven't done a lot yet. I'm still ramping up. The first thing, well, what I did right before I left for the holidays was finish up the refactors for 0.7 with Eric, which were mainly renames and also essentially tidying up the API a little bit in backwards incompatible ways that we had wanted to do for months. So those are shipped now, but I think Eric's going to talk about that. I also did a bunch of reviews. Mainly what I've been looking at today is a pull request from Eric to add a new API to create nodes from Go. So we had a package called Fluent to do this, but it wasn't very nice, and it wasn't as fast as doing it directly by hand. So we came up with a new way, and I think I refined it a little bit without making it slower, which might be a good idea. So I linked his version and my version on top of his, if anybody wants to take a look. I was also this morning poking at why Go IPFS is so darn heavy. So I've got there's a project that I contribute to that uses Go IPFS, and importing Go IPFS from Go means that you import like a bunch of Protocol Labs modules. And I realized that the binary was like 100 megabytes. So I started poking at that, and it turns out that IPFS itself is to blame for quite a lot of it. And I realized, for example, that Quick Go uses a library called GoJ for marshalling JSON for its logging, and GoJ weighs like over a megabyte. So I think that's pretty sad. So I was looking at that and poking Martin about it. He said he benchmarked it against the standard libraries JSON package in February, but he doesn't have that code anymore. So he's going to get me that code in a couple of days, and then I want to look at that because I'm pretty sure that we could get fast logging, because the logging is pretty simple without needing to add such a heavy dependency just for Quick Go. So anyway, this is just to say, I think Go IPFS has some heavy indirect dependencies that don't belong there. And I also, just for fun, over the weekend, did some analysis of like the most popular Go modules on GitHub. So if anybody wants to do anything that requires looking at tons of Go code, either for like analyzing a Go corpus of code, or like how do Go people do this or that, you can use this as a starting point to then clone a bunch of repos and look at them. And that's it for me.
Okay. Yeah. So I didn't do a whole lot since our last meeting. I did work around this JavaScript CBOR stuff. I almost made a pull request to JSDAG CBOR to change the CBOR parser out, but it sort of ended up wasting a lot of time doing benchmark stuff, trying to squeeze performance out. Also got this package that bubbled up out of it called IPLD, JS IPLD garbage, which is just a garbage data generator that makes randomized objects that conform to the data model. That's useful for testing and also benchmarking. And so that's what I'll be working on this week, this CBOR stuff, to get that done. As I said, the work is done except for performance tweaking. When comparing against our current CBOR parser, there's it's benchmarking is a little bit complicated because it's the current CBOR parser is turns out it's really crappy for one-offs. So if you just use it as a decoder or encoder just for a one-off, it's really bad. But when you do it in like a benchmark environment, you're doing a lot of decodes and encodes, and when you use it the way we use it in the codec, then it gets to do a lot of memory tricks, and so it ends up being quite reasonable when you're doing a lot of encodes and decodes. And so I'm straddling this line of not wanting to use the same tricks as our current seaball parser, which is very, the two problems are it becomes a memory hog because it has, one of the tricks it uses is to allocate these large buffers of memory and then just keep them around. And then the other trick it uses is it uses the performance optimizations of the node buffer to to squeeze out some edge performance. And I'm making this thing so it doesn't depend on that when you're in the browser. So straddling that line turns out to be a little bit annoying in terms of squeezing out the performance in comparison. So I don't have the performance wins that I really wanted, except if I compare these things in a doing one-offs. So I'm a little bit disappointed about where that currently is, but I'm currently doing a bit more squeeze, and I've got some additional nice features coming out of this thing, like the ability to pull out just the links of a seaball block without decoding the rest of it. I can do that. So I was going to add a links method to the codec. So instead of like decode, you could just do links, and it would just give you an ordered array of the links as they appear in the blob. And that might be an interesting shortcut to add to other codecs too, where that's efficient.
You should have it return not just the links, but also the paths to the links.
Oh.
Yeah, you kind of need both. Like if you look at the links method in the new multi-formats codec stuff, it iterates over it, but it always gives you the paths as well as the link.
Yeah, I guess for the use case I want, like I'm using this for the Filecoin data, and it turns out to give me some nice performance benefits just on decode. But what I really want is just to be able to do a sort of a raw crawl, and I don't really want paths. I just want the links. So because because it's going to add overhead then by doing paths, because you've got to do way more decode. But yeah, it's an interesting point.
Yeah, that's true. You'd have to keep track of the state a little better as well. I mean, I can see the use for both. It's just most of the time I do want the paths as well. But if you have a use case,
you need more state, but
no. You need to actually you need to decode the strings of the map keys in order to create the paths. Whereas if you're just pulling out the links, you can literally skip over all that until you hit it.
Yeah, and once you get into strings, that's where everything hurts. Like strings is like strings from binary is just the worst path for performance. So it's like once you start doing that, you may as well just decode the whole lot. that's the sort of the performance vector we're getting at here. Anyway, so
once they're strings, JavaScript is really good at them, but getting them to be strings is hard.
It's the bytes to strings and then back again, and UTF-8, and it's just anyway. So I wasted like a week on this, like in this sort of fury of coding and benchmarking, and in the end was way more disappointed than I thought I would be. Anyway, I'll get that done this week. That's my mission this week, done and published, at least in the initial form, and then move on. The other thing was the Go codec DAG PB. I've tagged that as a version 1 done. It works, it's good, and it's got the new Go test. What is it? The GitHub Actions test stuff that Martin did for Go repos, and that picked up that bug from last meeting we talked about with the int64s, which has been fixed in Go IPLD Prime and now merged back into this, and then that's all published and done and works nicely, and yeah, so good. That's me. Who's next? Eric.
So I did a bad job at taking a break. I tried to spend a bunch of the last couple of weeks building new applications for fun. And the good news is that I legitimately really wanted to use a bunch of our IPLD libraries and tools in order to get stuff done. The arguably good news is that ended up spurring a bunch of development work in IPLD things. So I actually, in a way that's constructive for IPLD. So one interesting thing that we now have in the Go libraries is there's a function in the traverse package called focused transform, which helps you do point mutations to existing document trees. And so that function basically lets you hand in a node that is the root of some document and a path that you want to do something to. And then it will call you back with whatever callback you give it and say, here's what I found in that document tree at that position. And please tell me what you want to replace it with. And then it'll go through and like rebuild the rest of the document tree around that in a copy on write way. And this works even if you have a path that jumps through several links in the middle into other documents. It'll rebuild all of them. So this is something that had been on the roadmap for ages, and I actually wrote it now. And it has tests, and I'm pretty sure it works. So this lets you do point mutations even in large graphs, and it'll do the right thing for you. Should save a lot of work if you want to munge documents like that. I also tried to make a more general form of that, which would let you specify a bunch of point mutation operations, and then the function would figure out how to do that most efficiently. And that turned out to be a little bit trickier, so it ended up going back to the design bin. I ended up working on some stuff that was really similar to, there's a JSON patch RFC out there. And ended up with something very similar to that. But actually implementing such a multi-mutation feature efficiently turns out to be really tricky. And I wanted to make something that's more efficient than just do a sequence of point mutations, because of course you can do that in a for loop and it's going to work, but like I don't want to go fast. If somebody else wants to think on that, it would be really interesting to see what we come up with. The hard parts that I discovered are, so if you want this to be optimal, you are going to want to have this function where you give it a list of the transformations that you want to do. And then the function is going to look at that and do something kind of like query planner type logic and figure out in which order it wants to do it in order to be optimal. And then that gets really tricky because not all of the operations that you're likely to want to do are actually commutative. So like changing something in a map, those changes will generally be commutable in the list because you're changing the same map key. So like, of course I can reorder these and not change the semantics. Or appending map keys is probably fine. But, okay, let's say we want to append to the end of the list. All right, still fine. Let's say we want to insert in the middle of a list. Shoot, not fine. Cannot do commuting of this operation because it will change the meaning of every other list index in the rest of your instruction set. Similarly, list deletes don't actually commute. And so then things just get really complicated because you would have questions like, okay, if I have like a bunch of insert operations that all say 0, so they frame shift the entire rest of the list, and then I do this thing, like, can I think if you implemented fancy enough logic, you could make some of these things commutable, but then like, how much pre-processing do you want to do to check that out versus like, and then you end up with edge cases like, oh, this set of operations is commutable if you're applying it on a list, but if you're applying it on a map, then it isn't, or like vice versa. It got hairy. So I put that back in the design bin, but if somebody else wants to look and think about that, I think there's interesting stuff to do there in the future. I think Danny earlier mentioned this, but he and I both started working on some new helper functions for creating data trees in our Go libraries. A quick restatement of the problem here is in the Go IPLD primary library, we've got these node interfaces and node assembler interfaces, and they're really rich and really powerful, and they very completely model the domain of the IPLD data model and everything you can do with it. And because they're so complete, they're very verbose to use and kind of a pain in the butt. And so we've always expected that we're going to have these node APIs that are really rich. And then we're going to make some much terser usability facades around them. And we started actually trying to make more of those. So I've got a PR up with one, and I think Dan's got a PR up with another one. Both of them are syntactically nicer than things we were doing before, and both of them also have a lot less overhead on benchmarks than anything we've done before. So instead of having an awkward choice between using one of our facades and having terse code, but a performance penalty, and then like potentially staring at a rewrite in the future, et cetera, we've come up with a couple of new options that don't have performance taxes, so you can just use them and it's probably fine. So we're still refining those, but that's exciting to have more options for. We tagged a release. We're really bad at holidays. We tagged a release of the 0.7.0 in the Go IPLD Prime libraries too. I think both people who talked already mentioned this briefly already, like ints have a fixed size now, technically a breaking change. A really small one is really easy to upgrade, but Daniel gave us said instructions for migrating all of these things basically automatically, probably. And those are in the changelog notes, so that should make upgrading really easy. The codegen now has support for string prefix unions, because I really wanted to use those in one of my other hobby projects this holiday, so it's done now. And I don't know, some other coding stuff that's too boring to bother talking about out loud. That's it for me.
I don't think string prefix unions are defined in our specs anywhere, are they? Maybe you need to do a pull request to schema for that. Byte prefix is there.
Oh, shoot, you might be right. Well.
Okay, Peter, you're up next.
Cool. So from me, the thing I have been working on forever is actually reality now. There is a database that does replicate. There is a link to a doc in which there is an actual set of credentials. So you can just log in, and this will be a replica that follows an actual Lotus instance that actually writes to the database, writes blocks, writes all their links already fished out. So you can actually do recursive SQL queries within the actual database and get blocks out, you know, as full trees, like figure out how much a state weighs and so on and so forth. It also analyzes every tip set that it sees and breaks it down into another set of tables with actual chain, you know, chain members, where are the messages, where are the states, and so on and so forth. So you can do full traversal of the Falcon chain without leaving your SQL console, more or less. Caveat, it is not the full state. It is from 362,500 block onward. So this is from about a week ago. This will continue working, needs a few tweaks to get it. Basically, right now it processes a tip set in about 7 seconds, which totally lets it keep up with the chain. But it does not let me sync from 0 to have the entire thing ever. I need to speed up to about 1 second per tip set, and then within a week we'll have the entire thing. Performance of the actual queries is as I expected. Replication is as I expected. The 600 gigabyte database got streamed to a new host in about 2 hours, and basically just booted up. And yeah, that's all I have. You know, log in, kick the tires, let me know if something is missing or doesn't look right, and yeah. So I have.
So you've got faster than Badger. So is there potential for just embedding an embedded Postgres in a future version of Lotus and just ditching Badger and that being the next upgrade for data store?
So for the archival ones, this is definitely what I'm using myself, because like the Badger thing is impossible to keep alive. It requires too much feeding. So what I have, like it's written in the doc, but very quickly, it does way more than keep track. It also, specifically for what you're working on, and and Alex North and Zenground, it keeps a record per tip set which blocks were read or written. Like it has the granularity, and it has like a huge log that it just keeps writing to, keeps appending. So you can literally, for a specific CID, you can see like who needs the CID and get a full list of where it was used and how. And there are like even wall times of how long between accesses and things like that. So it's super general on that level. And obviously, you don't need this for a regular install. My thing for that is that if I get it to a point where it is exactly where I want it to be within like 1 second range or something like that, instead of distributing these ridiculous car files with the snapshots that you need then to import and so on and so forth, I can start distributing an SQLite snapshot, which has just enough of the state for you, and you just insert the SQLite thing, which is just a file, into your data directory, and you just use that going forward. And because it is not like it's a single node, it doesn't need to be super performant, it will be good enough.
I guess to directly answer your question, Rod, more likely what you might expect is a future version of Lotus that has a flag to allow a Postgres backend. Probably it won't run Postgres fully, but if you've got, you would be able to use the same Lotus code and a local Postgres and a flag to have that be your backing data store rather than Badger.
Neat. Cool work. Okay, Michael.
I'm back. Okay. Yeah. So yeah, had some really good code time during my time off. It's been great. The big thing is that I wrote another implementation of the trees that we've been talking about for a while that me and Makola had been working on. This implementation, like obviously having done it a few times, but it's a lot nicer and cleaner. And one thing that I realized implementing this data structure is that it's just a lot cleaner to implement if you don't make some like serialization the centerpiece of the design. If serialization is like a thing that some of the types do, but like there's just it actually doesn't work very well if you think about it just in terms of like what the serialization paths are going to look like. So it's just like a much cleaner implementation of the tree. And then on top of the tree, that implementation has a bunch of data structures. So there's a sparse array, a DB index, an ordered map, a CID set, some other things, right? So it really works, and it's really versatile. It works in these different scenarios, and it also works like if you add IPLD serialization into it as well, which is what it does right now. So and then I use that to write IPSQL. Like it's a full SQL implementation. There's some pieces of the syntax that aren't there right now, but like you can create tables, and there are like full indexes of all the columns. And like I have a CSV importer, so you can take CSVs and import them in, and now you have like this IPLD-based SQL database. And when you do queries on it, you only pull in the parts of those data structures that you need for those queries. So I'm working on the demo piece of it now, where we kind of wire up some of the network stuff, so that over the network we can do these queries. But like even for these trustless queries over the network, if I want to just look at one particular index, all I'm going to ever pull is the data for that index and nothing else. And then I have that locally in cache. It's really, really nice. And the more time that I spend with it, the more that I realize that like we can do a lot with this, like beyond sort of basic SQL stuff. Like, yes, you want to support all the basic SQL features and have regular tables and columns and everything, but it's going to be pretty trivial to just say, oh, here's how to add a DAG table. And part of the DAG table is which paths do you want to index, like their columns. And then you can just do regular SQL queries over those over those indexes. And you get like all of the power of sort of the SQL query language when you do it. It's really, really cool stuff. So yeah, I'm working on like getting things a little bit more polished up and demoable. And then from there, it's just sort of like a grind of knocking through the rest of the syntax, right? Like I don't have alter table yet, and I need to work on joins at some point, like stuff like that. There's a few more comparisons that I need to implement, but SQL as a query language is really nice. Like where where you set up some of the combinations of different syntax features and stuff is really sort of well understood and predictable. And so it composes really, really nicely into an implementation of the query language. So I was able to make way more progress way faster than I thought. And now it just works. One sort of interesting thing that it uncovered, though, is like this contention in these advanced data structures between doing things in a streaming way or doing them in a fully concurrent way, where you really have to pick one. And so in the chunky trees implementation, like it is like become very common for me to make my write interfaces just be a generator. So you do a mutation operation, and that generator just returns you, and it iterates over all the new blocks, and the last block is the new root of whatever the mutation that you did. But I really had to put that down for this, because when you're doing big mutation operations, you can really concurrently parallelize over every part of the graph, and every part of the tree that you work your way down is like another concurrency vector. But in order to implement that cleanly, like you need to just use recursive functions that you do parallel. Like you can't map that into a generator cleanly. And the same thing actually happens in the reads. Like you could do these iterative reads, but it's actually way more efficient to just take the entire range query and go down the tree for the entire acceptable range of the query, and then just place it all together at the end. So you're going to use more memory, but it actually works pretty well. In IPSQL, I was able to kind of get the best of both worlds a little bit. Like if you think about what a table mutation is, you basically you're mutating the rows in the table, which is a sparse array. When you do that mutation, you get back the old values. And then you can basically kick off the updates for every index in concurrently. And so what I have there is like that mutation, the upper mutation operation is a generator. And so as I do the first mutation, I kick out those blocks. And then as all of the concurrent index mutations return, I also emit all those blocks. So it gets kind of the best of both worlds a little bit, where I'm not using up like an insane amount of memory, but it is like, doing everything as concurrently as it possibly can. So yeah, that's where that stuff is at. I think in a private call after we finish, I want to talk a little bit about some of the stuff that I encountered trying to wire it up to IPFS and libp2p. But we won't get into that now. We can kind of move on. And who's next?
Chris.
You might be me. Hi guys, I've been on vacation the last several weeks, so back now, and really my goal right now is to get the JS Graph Sync project transitioned over to the IPFS team this week. So that is my update.
Cool. Okay, yeah.
Good. Okay, so we've got a couple of other items on the agenda now. So first one is this. I think Daniel, this is yours. The in64 for lengths in IPLD Prime. Should we do that? And I will confess that this was an annoyance when I was using it. And it did feel like maybe it should just conform to what Len uses. But, it's not the end of the world.
Yeah, so actually I kind of changed my mind in the past 20 minutes while I was just listening and thinking to myself. Which sometimes happens. But my initial thinking was, if these high-level helpers are just for like quick things or like things where the performance is not the top priority, then taking int is possibly okay, because for non-constants like lengths of something, which are quite common, it means simpler code. But at the same time, now I'm thinking, well, but we also don't want to discourage using these for like actual good purposes, like big purposes. And also overflows in Go are silent. So if something overflows, it's not like you would notice. So I'm thinking, yeah, forget I said anything.
So hang on. So the flip sides are there's simpler code for non-constants, but what was the
points against, you mean?
Yeah.
Well, if I'm happily using the wrappers, the high-level helpers with ints, not in64, and then suddenly my code uses something that's very, very large, the overflow would be silent in Go. Nothing is going to warn you about it. So that would be a big no-no. And you might
so
also
it's the same argument for explicitness as for in64 everywhere else.
Yeah, and also, even if the user knows what they're doing, do you want to really encourage them to use the 10 times more verbose stuff just because they actually use larger nodes, which doesn't make a lot of sense either.
Okay. Is this something that will sort of shake out with use, that it might be something that people complain a lot about, or that you get annoyed at by using it a lot, and therefore you need to revisit it? Like, leave it as it is for now and revisit it if it's a significant annoyance in use?
I suspect it's going to be moderately annoying because using anything that's not the underspecified int in Go is moderately syntactically annoying. But I think what would be worst is if we did a mixture of them. That's just really high cognitive overhead and really, really frustrating. So going uniformly with int64 across the board seems like the safest choice at this point, and I kind of doubt that we'll be forced to revisit it. It will be probably perceived as moderately unfortunate forever, but it'll be one of those things where every time somebody looks at it and reviews it again, they'll be like, oh, yeah, that's how it's got to be.
Is there an argument space here where somebody will come along and say, well, for length, you really should be using uint64? As long as you're doing a custom int length, int type.
On that one, I think people come around and say things a whole bunch.
Yeah. Okay, so leave it as it is for now, at least.
Yeah, on just a note on the int versus uint, the reason actually Go is using int for a lot of these places is not because, like in C, they have to signal -1 and things like that, but because the overflows are noticeable. An overflow on a uint is really catastrophic. An overflow on an int just gives you something negative that nothing understands and everything breaks. So that's a thing to keep in mind.
Right, so if we have anything with a length that's greater than int64. Okay.
Yep.
And also, as a silly variation on that, if you have int64, you can use -1 as something that's definitely invalid, which you don't have an option in uint64.
Okay.
My opinion on this is at some point these things become bit strings instead of actual numbers. If you're worrying about these edge cases, you have already become aware that these are bit strings and you are not treating them as numbers anymore. And so if that's the life that you have chosen, fine. Then it's a 64-bit bit string and enjoy. I don't care if it's negative or not, that's your problem.
Well, speaking of, that leads us perfectly into the next item,
oh boy.
Which is IEEE 754 leakage into the data model. There's issue 342 in the specs repo, which is a really interesting one. So this is, IEEE 754 defines infinity, negative infinity, and then as things that are valid in, like, you get them when you have floats, and then they use IEEE 754. And there's a binary format for them. And so Seaboard bakes it into the spec as well. And so both our Seaboard codecs give you these free. So in Go and in JavaScript, these will do a round trip smoothly and per spec. So this issue started with somebody saying, well, hey, can we add this to DAG.json? And there's a proposal for doing it like we got bytes and links. And so the discussion then is about, okay, well, then we have to confront this thing and say, is it something we explicitly support? Is it something you just happen to get free by a codec that supports IEEE 754 in some way? Or is it in some other space? So I've tried to lay out the various questions that need to be resolved for that. We don't need to resolve it today, but engagement in that issue would be good. But if anyone's got any thoughts they want to drop in now, we can have a quick discussion about it.
I think I agree with Eric that we should just reject them. Like they're less agreed upon between languages than anything else that we support. And it's just, it feels really painful to try and deal with them. Like, because cross format is not going to work, right? Like there's going to be, like we can't do it in JSON. So it's JSON's out unless we want to do more crazy type customization than we already have. We hate it. So I don't think that we want to do that.
But we have a precedent for bytes and links, and which is what that issue is proposing. So it's not impossible. It's just messy. And it's like, it's like if you accept these things, it's almost as if they become top level kinds.
But is it a given that every language has a consistent type for infinity and nan? Nan in particular, I would be surprised about. Like, I don't think that every language has a nan.
I think so. If you support 754, these are baked into it. So I think they come along with the cake.
Is everyone 754 compatible?
Probably not.
Mm-hmm.
Well, that's the thing is that this is not 754 is like, we don't, when we say float at the moment anyway, we're not saying this is 754. Yep. It's just right. It just so happens there's this alignment with 754 in DAG CBOR. That's really, that's where we're at, is that there's this overlap. And so it's like this Venn diagram where it's mostly overlapping. But when we could just jump all in and say, well, when we say float, we mean 754. Or we could just say, when we say float, we mean these things where you put a dot in a number, and that's it. And what happens in the codec happens in the codec. And we don't recommend you use them. Is really, we need to get that out and say, look, this is not recommended for these various reasons.
I mean, there are formats that like we want to be able to use in IPLD that don't have these types, right? Like JSON. And if we know that that's an issue, then I say that we just kind of punt on them. It's fine.
So I would also like to just flat out read the definition of IEEE 754 NAN from Wikipedia, because it is worse than you think. The sign bit may be either 0 or 1. The biased exponent must be all 1 bits, but the fraction component can be anything except all 0 bits, because all 0 bits would represent infinity. So how many bitwise not equal values are there, which are an IEEE 754 NAN? I don't know. A fuck of a lot, that's how many.
That's crazy.
Yeah, like, so can we do IPLD? Hard no. Hard no.
Man, we actually have to say no to that index CBOR just for determinism issues. Like we can't have people getting different hashes for the same data.
Yeah, but DAG CBOR does narrow it down to just one. There's just one way of doing that.
Right, you could have a canonical representation of what your
they
NAN is.
do that though. Okay. You made it sound like they're just pointing at like 754 and saying that's our float and like that's where we get NAN from, and not like actually saying, oh no, like specifically NAN is only this binary form.
Yeah, no, it's just that I think the 754 spec does specify bit layout simply because it's to do with how you do with arithmetic with it and all that sort of stuff. Whereas CBOR comes down to, well, there are these 3 specials, and these are the bytes that you encode them as, essentially.
Okay, that's good.
So it's compliant, I guess, rather than.
It's less terrifying than I thought it would be, but that's still like, I feel like that's still like a feature of CBOR that we don't have something in other formats to do. Also, just like philosophically and conceptually, like it really bugs me that you can serialize infinity. Like, I don't know what about my brain hates that, but like, no, that's not like a real thing that we've agreed upon.
I don't know. You can write it down. If you can write it down, isn't that enough?
I mean, like, it's like the string infinity is consistent to me in a way that like infinity as a conceptual number value is just not.
I think if you push on that, then you end up having the same problem with floats in general. Just encoding floats for a lot of reasons is weird.
I feel like those issues are less that like we don't have a mathematical model for what a float is. It's just that like our computing model for floats is a little weird. Like the way that we have to do math on them in computers is actually difficult. It's not that like literally in mathematics we have not agreed upon like the best way to treat this, right?
Okay, so Michael, you might want to put your vote into that issue there so that we can can angle towards a resolution for that. It does sound like that. I was leaning towards more leaving it maybe in an undefined space. It's like there's codecs that will do this, so you shouldn't rely on it, but codecs that won't, so you shouldn't rely on it. But maybe this is an area where we just need to be clear, because it's like in at the moment you can encode undefined in JS DAG CBOR, but but Go IPLD prime and Go DAG CBOR will reject that on decode because it doesn't know what to do with it. So we've got this problem with undefined already that I'm in the process of fixing. I'm going to reject undefined as something that you can encode. It's just going to go. But that's in a similar space where there's this thing that you can do, but maybe you shouldn't. So maybe we should rule it out.
I'm also just like, we tend to talk about these things as like, how do they map onto existing formats and languages? But another thing that we need to keep in mind is how do these affect us as we build more native formats? Yeah. Like, I do think that we're going to have more block formats like being engineered as we move forward. Some of them, being much more customized to particular use cases. And the more things you have to implement, the harder that will be, and the more surface area for bugs and inconsistencies. So just keeping things smaller rather than bigger seems better to me, especially when there are areas that we know are going to be difficult to do compatibility on.
Agreed, as long as it doesn't impact too heavily on the likelihood that people will use our stuff.
If it's not in JSON, I have a hard time believing that people are using it so much that it's a non-starter for us not to have it.
Yeah, and mostly these values they're always used as just these symbols, these tokens that you use for sort of edge cases of things, and you can use anything as a token. Like make yourself a special string. Like it's Okay. Anything else before we stop the recording?
And I did a little bit of poking around at some stuff over the over people's time off, and so I mentioned this to you guys a while ago, but the ability to basically download a large block in increments by just downloading it backwards. If it's SHA-2, if it was SHA-3 and anyone was using SHA-3, you could use a Merkle tree, but if it's SHA-1 or SHA-2, it's a streaming hash, and so you can download it backwards. Another thing I was thinking about this was that, so Hannah put up a proposal recently around sort of GraphSync and BitSwap to basically use GraphSync to grab a manifest of all the blocks in a file, and then just send those over to BitSwap, and then grab all the blocks in parallel from whoever.
This is exactly what I just figured out that I need to do for IPSQL. Actually, is like it's using RPC instead, but it's literally like do the query and then tell me all of the blocks that query needed, and then I will ask you for the ones that I don't have.
Right. All right. Yeah. So this was interesting, and what it sort of reminded me or pointed out to me is, for a while my understanding was BitSwap has been in these restraints, which is the reason why we have a block size at all, right? Why have a block size? The reason to have a block size is so that you don't download an arbitrary amount of garbage before realizing that it's garbage. But that's a lie because GraphSync does that. In fact, it's the only way you can do it. If I have like a linear history or a blockchain or whatever, if I have to go one block at a time, there is no protocol in the world you can write that will make this fast. The only way it works is if I download multiple blocks at a time and I just verify them when I get the chance, right? If your pipe is faster than my CPU, then you just send me more garbage and I'm okay with that. And then if you're going to be okay with this, then you have to set some parameters, like how much garbage is okay, right? How much trust am I willing to have? Is it 1 megabyte of trust? Is it a gigabyte of trust? Does it scale based on the fact that you've sent me 100 good megabytes in the past, right? Those are things that, I don't know, we just like the hardest problem in BitSwap because it was impossible. We just sort of ignored and we're like, GraphSync, it fixes all our problems. And like, no, we just skipped the answer. Which is fine if we're all on board with that.
So
that's not the case.
Yeah. So I want to unwind a couple things. So one is that in a GraphSync request, there's a deterministic ordering to the request. So there's actually a deterministic order to the blocks. And so if you're getting them one at a time, you actually can validate them one at a time, that they're required for the
but
query,
I receive
because you would literally be asking for them.
Sure, but I receive 10 blocks when I've only had time to validate the first block.
So
I've downloaded 9 blocks that are in theory garbage before I realize the first block is bad.
That is only because of the way that the protocol is implemented. That's
no,
not
you can't do it a different way without being slow.
No, I can start the query locally before I get any response from a remote. And so when the first block comes in, I can decode that and I know what my next block get is, like literally synchronously before I even ask for the next block, which would be when the next block comes off the network. If like, so you actually, you should be able to never keep a decoded block in like buffering. It may be the case that the network has a bit of a buffer going on while you're processing some of them, but like in your code, you could literally have it be that like, if I get a block before I've asked for it, that's invalid and kill the connection. The reason you can't do that is because the way that GraphSync is implemented is on like separate streams for different control flows. And the way that you have to wrap that on top of itself, it literally just defies streaming. like there's no way to like set up the flow control so that I know if I needed this block yet or not. You literally just have to defer everything. And so like that's why it's implemented this way, and that's why we have this problem. But like in theory, you should not have this problem if the protocol was engineered better. You would be able to never keep a block in buffer.
I mean, this isn't true though. Like imagine I have like a 100 exabyte per second pipe and I'm running my GraphSync program on a TI-83. I will receive more data than I can process in time. Like it's just like fundamentally this doesn't work.
No. Like watch the whole control flow. Watch the whole control flow. Okay, you get 100 megabytes into your network driver. Okay, the network driver like sends the syscall that says like, hey, I've got data here. Your program pulls off the data off of the network. It decodes the first block. It now hands the first block to you, and when you decode the first block, you synchronously decode that block into CBOR, traverse it. You know what your next block get is. You start your next block get into like some kind of defer the future pattern, saying like, give me this once it's processed, before you have any ability to process the next block get. So like if you are actually streaming the blocks and yielding them into the program as they get streamed out of that buffer, you literally do end up in a state where like, yes, the network driver might be buffering a lot of garbage, but your program's memory doesn't. You can actually, if you have the control flow, you can do this. We break the control flow, so this is not true for any of our programs. So you can basically ignore what I'm saying. But like, if we did this right, this would not be like, you could do this.
And to add to that, the reason we have a block limit is not for the garbage in general, is so that in the individual block that you can hash and that you can pull further links out of is within a bounded time. Because otherwise, the very first block that I sent you might be a petabyte of data, and you never know where this hash ends.
But so so those things are related, right?
Mm-hmm.
Yes, but they're different.
Well,
Mm-hmm.
I argue that it's not as distinct as you're making them, because your network, like
mm-hmm.
My machine is downloading the data. It's getting like, it is making its way through my router, which is the expensive part.
Mm-hmm.
Not the SHA-ing on my side is not the expensive part.
Well, but your router will start dropping them when there is enough back pressure on the actual hardware level, even UDP.
Yeah, eventually, yes. Eventually, blocks will start dropping, right? But this is the constant, right? So there is a constant, which is how much garbage am I willing to download before everything falls apart? And we were assuming that we could set that in software and just say 1 meg, but like, not really, right?
Yeah. The 1 meg does not protect your network stack. It protects your process memory space. That's what it does.
Yeah.
Right. So if you wanted to do that, if you choose to do this thing where you download a whole petabyte, but you download it backwards,
mm-hmm.
you can incrementally set your memory thing to still be 1 meg. And you still download the whole thing, because just like with the GraphSync thing, where you're sort of trusting ahead of time to get a bunch of data, but then you're verifying it when it comes in, you can do the same thing with this.
So a couple things. One is like, I agree with you that like this particular thing does not do that, and that is something that we say that it's for. But there's a bunch of other stuff too. Like a lot of decoders work serially, so you're going to want some block size, maybe not a megabyte, but some block size. There's a lot of reasons actually to keep blocks small just outside of all of this, right? Like all these data structures that we're mutating all the time, like we actually do want to keep the block sizes reasonably small so that we can cut down on the mutations, right? So as far as like the protocol design goes, we're always going to need a way to do efficient, like lots of blocks efficiently, right? Even if we get out of some of this other stuff. Lastly, I love the idea of getting them backwards so that you can stream the decode, but this would also require that you eat a mem copy to reverse the buffer before you write it to the socket. And so you're going to eat an extra mem copy for every block that you want to send using any protocol that relies on them coming in backwards. And then when you get them, you're going to have to do another mem copy when you reassemble it.
Well, either way, so what I was thinking was you would... So there's like sort of the next thing of this, which is if you assume you can have large blocks,
mm-hmm.
what you might say is that there's a very common scenario where you have multiple ways of describing the same data, one of which is as a single large block and the other is as a tree of small blocks, right? This is like files, right? And so I can store the file data as a sequence of small blocks. So I download the block, I download the 1 terabyte block backwards as small pieces that all live in my block store as individual pieces. But then I've strung them together with metadata. And so I can say, oh, I have this file. It's chunked up this particular way, but also you can have the file as a single block, which means that if someone requests the file from me as a single block, this works. So I can go to the canonical website, find the SHA-256 of the Ubuntu ISO, search for it on IPFS, and someone will be able to send it to me, because there is a way to deterministically go from this one large block to me, and even to do it in parallel.
I mean, isn't that kind of what a car file is? Like there's a little bit of extra stuff in the header, but it's basically what a car file is.
Except that the identifier is this identifier that's like everybody already agrees on.
Well, but for your Ubuntu ISO, won't the chunking have to be pre-agreed on the same way?
Yeah.
No, there's no chunking. This is so part of this.
Yeah, it's the
there's zero
construction.
Chunking. There's zero chunking. It's SHA-2 of the whole file.
Yeah, but for people to be able to stream it to you securely.
so I can actually choose. As the client, I can ask you to stream it to me in whatever way I want. For instance, I can say, I want you to start sending me small pieces, and then as I trust you more, I want to start you sending me bigger pieces. Like I can choose the construction if I want to.
So you almost want to send the chunking strategy as a client, and the provider will chunk it this way and send it back to you. Yeah, that's that'd be nice, but I don't know if we're there yet.
Well, so it's not, the thing is that I don't even think it's like that I mean, the things that you would need to do to make this happen, right, are you would need a way when you add files, when you add files to IPFS, you would need to store a second DAG, right, which is, or a second like metadata sort of thing, which says, hey, this is the hash when I string all of these together. And here's the list of the pieces that go to them. And then I would need Bitswap to know that it can ask for this like virtual object.
I mean, it doesn't work well for mutations, but
oh no, it sucks for mutations.
But there's a lot of data that we don't actually mutate.
And it's not to say you can still store it as a graph, right? Because the individual pieces at the bottom of the thing are just one form of it, right? I can still have them chunked up however I want.
So, but how useful is this though, right? Because when you have text data, you want to use, like ideally you want to use some kind of chunker like Raven, where you get better semantics when you mutate it. When you have data formats that are effectively binary formats that don't mutate well, you probably want a data type specific chunker, so that like it's already chunked up into blocks and you're going to get full blocks essentially, as you might want to seek around the file or hand it off to a decoder. So like if it's a video file, you want it around the keyframe boundaries because that's like the unit that everybody will always need. Or potentially like, in certain zip files and stuff like that, like you can actually bounce around and seek into it if you chunk it up appropriately. So like a lot of these formats actually just have ideal chunkers and you would want to do it variably.
Sure.
Anyway.
So you'd want to. The advantage here is like backwards compatibility with the rest of the internet, right? Everyone who hashes a file, you can now just search the hash on IPFS and see if you find it. And the other one is that I can now like change my chunker without it being a total game over scenario. There's still going to be there still may be an optimal chunker, and we'll still be able to like, share the CID that includes the graph with the chunker stuff. But there is a canonical representation for files.
Yeah. I mean, frankly, we should just put the hash of the whole file in the file metadata anyway, right? Like, there's no reason not to if we have it. Like, it's a useful thing to have around if you want to compare to other files. And like, it's going to be insecure the same way that the length is insecure. Like, people can fake it. But like, we already have a precedent for that. Like, we already have another property that has that. So,
but it doesn't help me find it, right? And
know
that I can download it.
No, it does. It does. Like you just put a record in the DHT for that, and then like people find you and they go like, "Hey, do you have a file with this hash?" And you go, "Yes," and then you stream it to them.
And then you download a terabyte of data, and then you don't know what it is, right? Like you need this. You need this way of like verifying you're not downloading an unlimited amount of garbage, right? It's like a fixed amount.
And then the question becomes, which cache do you publish? Is it always SHA-256?
Yeah,
that is.
It's always SHA-256. Like that's the thing that everybody has.
I mean, it's the one. I would say it's like this. It is the one that is the IPFS default, right? So that you have a canonical thing, and if everyone decides, if IPFS is SHA-2, and then later on we switch to like SHA-64, then everyone all of a sudden starts publishing using SHA-264 as the canonical one, because that's the canonical one that everyone's using now.
Well, everybody on Lots is already publishing UnixFS Blake, so
Oh yeah. This conversation also reminds me of something kind of crazy that I should bring up. So this is like very early stages. Like basically, a friend of mine who does a lot of web standards work reached out because he's starting to work on some stuff that is like kind of in the space that we're in. what he essentially wants to do is that he wants to make bundler performance in the browser like a lot better, so that you can get like, you can sync bundles, you can get just kind of the parts that have changed of a bundle. So the bundle maintains some understanding of what files it came from and stuff like that. And so and to do this by like basically adding a lot of like code to the tools that create the bundles as well as the browser, and have kind of the transport and everything in between be pretty simple and stay the same. But like as we're sort of, and like what he's landing on is like, oh yeah, this is what Merkle trees are for. Like clearly, like this is like what you do with a Merkle tree when you want to do this kind of structure. And so we've been batting around some ideas, but like I think one place that it might end up is there'll probably be some kind of a manifest file for this at some point, so that like bundlers can reprocess really easily. And I think that we would probably be able to create an IPLD codec for that manifest that would surface a data model representation that conformed to whatever we want Unix v2 to be. So these could literally, like these manifests could be valid files, and all the links in them be the hash links to the rest of the file. And we could like effectively like interrupt with what the browser is doing through the codec layer, because they're not going to do exactly UnixFS, like they can't. Yeah.
So one of the things with this that was like, when I brought this up, like whatever it was, a couple months ago or something, the thing I was concerned about was like, I didn't know how I was going to describe these objects, like this download the file backwards object. And so this approach says like, it's just don't care about it as an IPLD thing, care about it as like a network transport thing.
Mm-hmm.
Which does circumvent a lot of those issues, but it comes with its own things. Like it means all of a sudden like Bitswap has to know about how to break up a SHA-2 thing, and it has to know how to break up a SHA-1 thing for each hash function.
I'd just do a new protocol. Like I wouldn't try to I wouldn't
whatever.
Try to, like,
I don't care.
Yeah.
Whatever you call the protocol. I don't know.
Yeah. I mean, Bitswap is like not like that difficult to supplant, right? Like, and once you start adding so much optionality, like the ease of it kind of goes away. It's like not really all that useful.
I mean, to be fair, Bitswap is like a trivial protocol with all of the sessions stuff. So if you could extract the sessions out of Bitswap, then Bitswap would be like 12 lines of code. I mean, it says, I have block, please give me block, right? All of the intelligence is in the sessions. So whatever you want to call it, right? It's just, here is protobuf with options. Please send me back protobuf with data.
I just wish I had that library that does just that thing that you're talking about. Like that in JavaScript is actually just not a thing that you can do. You can't use the Bitswap implementation without like taking on sort of all of the infrastructure, or like half of the infrastructure.
Although JS Bitswap doesn't have sessions, so I don't understand.
No. It's not that. It's like you got to take in the block store and you've got to interact. Like it doesn't. It's not like, hey, like here is a block. Tell me when you get asks for blocks. Like there's no interface like that. It's like, no, you conform to our block store abstraction, and then you wire up the block store to this thing.
Okay.
And, yeah.
The other part of this discussion that I've seen thrown out a couple times is can we have these custom chunkers as WebRTC or as WASM modules that get packaged with data? So the data somehow links to its own decoder, and now you've got generic decoders rather than having that need to be a predefined set in your standard library.
Actually, for streams, for flexible bat layouts, you don't need decoders. You need an encoder to basically tell ahead of time what its root CID is going to be.
Mm-hmm.
The advantage being, I mean, yeah, obviously, like, yeah, if you know if you know how to do chunking, that's good. But where are you gonna put the chunking in front? Like, are you gonna distribute that with your CID? Like, why do I need this?
You link to it in whatever the root of the data is. So you
it just says this is how to decode the rest of the data. Fine.
Right.
Yeah.
So like one of the things that makes it really useful, right, is like say it's Raven, right? Say it's just the Raven chunker with some settings. If that's at the root of my file, then if I take that file from you and I mutate it, I know how to rechunk it up ideally, and I actually have the program to rechunk it without, you know, including it as an external dependency or anything.
But
yeah.
Once we get there with this thought of there being code associated with content, which is already potentially a thought, you could imagine rather than saying, okay, we're going to have this metadata of the SHA-256 of the overall file being this extra field, and maybe we'll have those in the DHT, that you could have arbitrary identifiers going to something about the format that's associated with them. So that there's, you know, when you have that SHA-256 of Ubuntu that you are looking for, what that could be pointed to is the manifest that has that SHA-256, but also the validator, like code that helps you do smart decoding based on that format and gives you some verification.
But
the coding, because you need to, it needs to be verifiable, right? So the key with the downloading backwards, and like you can move the blocks around a little bit, but like the key with that is that I can tell you how I want the data, and then you send it back to me in a way I can verify, right? So having a manifest of all the blocks doesn't really help me unless the manifest comes and it looks exactly like the form I'm expecting it to. And then I can start downloading blocks and verifying them bit by bit, but I can't verify them. It's like there exists.
I guess the other thing I wonder here is there not a compact and efficient to verify zero knowledge proof that could link two things, so that you could provide also a proof that the SHA-256 is equivalent to the resulting hash of the data of the manifest, so that I can do that translation without getting the whole metadata chunk in an efficient way and skip all of this extra discussion.
Yeah. Dean, I think you did forget one important point here, though, which is that, like, if you have a really large file and you have just the SHA-2 of it, you can validate the entire file going backwards no matter how you get the chunks, but only if you only get them from one party. You won't really be able to very efficiently get them from multiple parties because you can only validate one piece at a time as you work your way backwards over it. Like
this is where the graph sync, but this is where like the graph sync knowledge or understanding that we are already taking in extra blocks comes in, which is I just set my parameter, which is I'm willing to download 10 blocks of garbage at a time, right? And then I can parallelize, I can ask, I ask Will for a manifest of the next 100 blocks, and then I just shoot out to everybody around me 10 at a time.
Yeah, I mean,
and I build up more and more over time as I trust Will's manifest more and more, because the first 100 blocks look fine, so why wouldn't the next 100 blocks look fine?
So I remember a lot of these discussions happening in BitTorrent when the protocol was still being engineered. And like a lot of this kind of stuff came up, and there's a lot of optimizations that you can make and a lot of experiments that people did. And like where I don't remember all of the exact reasoning and if it still applies, so maybe it's outdated and we should reevaluate it. But like, I do remember this general learning that there was just like, look, if you keep the blocks small and you have smaller just units of validation, everything else gets easier. And trying to do anything below that validation or trying to increase the validation, you end up with all these other long tail concerns, especially once you're under attack. And I mean, that's another thing too, is like a lot of this stuff started happening and becoming much more important as the BitTorrent network was more under attack, where people were trying to do negative things and giving you some good blocks before they would give you bad blocks and stuff like that. Like, you had like the MPAA and other actors like intentionally trying to, poison the network. So yeah.
Yeah, I mean, although like again, everything is like, we'll say like trade-off dependent. Like maybe if I'm willing to say like, okay, I'll just do like geometric growth and I'm willing for half my blocks to be bad if someone's actively attacking me. They have to give me half of the file I want before they can send me an equal amount of bad bits.
I don't know. I mean, if you look at this from the point of view of Filecoin, right? It's like you're doing the incremental payment channel, so you like this bad block size thing, like is very low. Like, yeah. Like,
what do you mean
this
it's
would
very
be
low?
so the incremental payment channel, you're only paying for the blocks that you validate through the graph sync request. So you can't actually allow the buffer to get too large, because then they'll actually just stop sending you data if you haven't been sending them acknowledgements, because you stopped paying.
Yeah. I mean, it becomes, I mean, things become both easier and harder with payments. Mm-hmm. So it's like a separate issue. But this is just like, I don't know. I guess I found it slightly crazy that like if GraphSync is willing to sit there and like eat up and just have this like segregated block store of quarantined blocks that it's waiting to verify, then like we can do all these things in BitSwap, and it's like so easy.
Don't look to that as like the oh no, they can do that, so it's fine. Like, it's not fine. Like, it's really not. Like, there's tons of bugs in this and like problems, and like, you know, like, it's really slow right now, and the lack of flow control in streams is really hurting. It's really hurting performance. Like, and nobody thinks that it's a great idea. It was just like the only way that we can get things to work right now. Like, I would not like baseline decisions on this existing. Like, it should really go away. Like, it should get fixed.
Yeah. Like, again, I linked it to this like set of issues that I and Michael wrote that are all about we use GraphSync, we cannot do all these things now.
Yeah.
But those aren't related. I mean, those are related to, you know, some of the interfaces and requirements. This is just like, at some level, I have to be able to download more data at once. Mm-hmm. More data has to be. I mean, if the latency is really long, you have to start sending me blocks even before I've verified that I actually want them, right? Mm-hmm. Maybe I can ignore some of them when I get there, depending on how big my buffers are in my network and my OS and my program. But like, you have to start sending me data before I'm ready for it. And so we can take a similar approach in BitSwap.
Hold on, but the client is never protected from you sending data. The only thing the client can do if you send that data is sever the connection. So all that's happening is that like the client can send you bad data until you realize it and it severs the connection. And the longer that you make that buffer, like the more that it's going to be attacked, the longer that we move out in this. Anyway, can we stop the recording now? Because this dovetails into a thing that I just wanted to talk about in Pratt a little bit. You said something, Rod, but you're muted, so I didn't hear it.
I was just going to say if there's any questions on YouTube, but there's not, so